Hey guys, it's Mike and Kyle back again with another Cooking with Chemistry episode. Today we're going to be making ice cream. As many of you guys know, it's getting hot, summer's coming, and what better treat for all you kids than some ice cream. So we're going to be reviewing colligative properties, freezing point depression, and how this ties into making ice cream. It's simple, easy, all the ingredients are available at home. You just need some ice, salt, sugar, a plastic bag, and a couple other ingredients, but enough of that. We'll get to the kitchen and get started.
So right now we're going to review some of the ingredients that you guys are going to be needing to make this ice cream. So we're going to be making ice cream for two. So of course we're going to have 2 plastic bags for each person. 1 little bag, 1 big bag. Of course, ice cream has to have the sugar in it, so we're going to have some of that. Salt. This is going to act as a solute when we review the chemistry principles. Vanilla ice cream. We're going to be making vanilla ice cream, so we have some vanilla extract. Of course, we have some ice as well, and some half and half cream that we have to use to make the ice cream as well. So.
Yep.
Alright guys, so here's a basic recipe of how we're going to be making this ice cream. First thing you're going to want is 2 cups of the half and half or the whole milk that you're going to be using. Then you're going to add half a cup of granulated sugar. This is all going to be in the big bowl, and then we'll put it in the bags later. Then 1 tablespoon of vanilla extract, 8 tablespoons of rock salt, and lastly, it's going to be 10 cups of ice. So you mix all your ingredients except the ice in this bowl, then you put it in the bags, and then you put in the ice and it freezes up the ice cream. So.
Yep, and this quantity should feed 4, so we'll test that out.
But me and Kyle could probably eat enough for 2. So.
Yeah. So now that Mike has finished stirring all the wet ingredients, we just transferred it into a pouring device, a pitcher, for easy access into the smaller bag. So we're going to take our small bag like so, just open it up, and you can measure this out and have it be completely accurate, but we're just going to eyeball about half of the wet mixture into this bag, like so. And that seems to be good, so I'll give that to Mike to seal up, and he's going to make sure that there's no air in the bag. Very nice and sealed. As close to a vacuum seal as you can get. We'll do that with this one. And yeah, we'll work on getting these all sealed, but yeah, that's the next step in the process.
Alright, so we still we have our 2 mixtures here in our bags, so that's going to be our ice cream mixture, and now it's going to be time to put in the ice into the larger bag. So what we're going to do is we're going to add 5 cups of ice to each bag, 10 cups total, along with 8 tablespoons of salt into the larger bags, and this should freeze the ice cream into what we all know it as. So.
Yep, so on to that part.
Alright, so now that we have shaken our ice cream for 5 to 7 minutes, we're going to take it out of the bags, put it in the bowl, and it should be ready to eat. Of course, we have some whipped cream to eat it with. So guys, now that our ice cream's finished, you're going to want to have a closer look. Put the whipped cream on it, and it's looking pretty good. So colligative properties in chemistry are properties of a mixture that relate directly to the ratio of solute particles to solvent particles. Colligative properties can be such things as freezing point depression and boiling point elevation. In our ice cream lab, we used freezing point depression.
So for this ice cream lab, the success of our ice cream was basically rooted in the way that we were able to decrease the ice's freezing point, which is known as freezing point depression. So in a standard use of ice cubes, the ice cubes that you would get out of your freezer, for example, they're typically at 32 degrees Fahrenheit because this is the standard freezing point of water. So if you were to put the ice cream liquid mixture in a bag of standard ice cubes, you would be trying to expose it to the temperature that it needs to be 32 degrees, and that is the temperature of the ice. So what would happen is the ice would probably melt before your ice cream thickened and became a frozen mixture. And this is not what you want to happen. So with freezing point depression, we can get the freezing point of the ice to be lower than 32 degrees, which would more readily cause the ice cream mixture to freeze and thicken into our ice cream mixture. So how we did this is we used a particular solute particle, salt. So the salt interferes with the ice freezing. So when ice freezes, it forms a lattice structure, and with the solute particles there, it makes it harder for this process to be underwent as it gets colder in temperature. So the freezing point had to be lowered below 32 degrees for the ice surrounding the ice cream to be frozen. So at this lower temperature, the ice cream mixture was surrounded by a lot colder temperature, and it was able to freeze and thicken into the ice cream that myself and Mike, enjoyed much more quickly, and the ice did not melt before this process was underwent. So that is the chemistry related to this very enjoyable summertime chemistry lab.